Hey all, today we are going to stick with the right triangles theme as that is the unit, and we're going to talk a little bit about trigonometry. And trigonometry is a big word, it's a funny word, it's a word that usually scares people off, but it's not so bad, and I'm going to refer to trigonometric or trigonometry from this point forward as just trig. So we're going to talk about trig functions. So there are three trig functions that we're going to focus on for our class. And what these functions are is it's just a relationship between an angle in a right triangle and two of the three sides. Okay, we give them sort of complicated, funny-looking names, but all it does is describe a relationship between a specific angle in a triangle and two of the sides. So if we look at this picture I have, we want to refer to this angle of the right triangle, and they call it angle X. And so in relation to angle X, we have a side that's opposite of that angle. We call the opposite side, often labeled with just the letter O. We have a hypotenuse in this triangle that's always across from the right angle. And then that other side we call the adjacent side. It's the leg that's right next to the angle we're concerned with. And again, I'll typically label my triangles using O for opposite, H for hypotenuse, and A for adjacent. So what we have are three relationships. Uh, the sine function takes our angle X, I want to highlight, takes our angle X and relates it to the side opposite from it, divided by the hypotenuse. So if we write a ratio of the opposite side over the hypotenuse, that is a sine function, and it's just a relationship as it relates to our angle. The cosine of that angle is the adjacent side divided by the hypotenuse, and the tangent is the opposite side divided by the adjacent. And this is a function. It's not like sine times x. It's the sine of this angle. And so the thing that goes here for x would be an angle measure. So we're pretty quickly going to be able to plug an angle measure in there, and there's calculator functions for that, and I'll show you that better in class. And so we can shorten these functions up, and we have a short couple ways to remember these relationships. One of the common ways to remember is SOH. So sine O over H, cosine A over H, tangent O over A, SOH. Another way I remember is that Oscar had a heap of apples. So I'll always write my functions as sine, cosine, and tangent, and remember Oscar had a heap of apples. So it's good to remember these. There's a couple shortcuts like I just said. You find the way that works best for you. It's also best to write those things every time you use them. So I want to write the three trig functions over here as they relate to z. So I'm going to highlight z. And then I'm going to show that 18 is my opposite side. It's opposite from z. 30 is my hypotenuse because it's across from the right angle, and that leaves 24 as my adjacent side. So it's good to write out the three functions every time, and now I can just write the relationships. So the sine of z, and you'll see I put z in there, is the opposite side 18 divided by the hypotenuse 30, and then I simplify that to 3 over 5. The cosine of z is the adjacent side 24 divided by the hypotenuse 30, which simplifies to be 4 over 5. And then the tangent of z is the opposite side 18 divided by the adjacent side 24, and that simplifies to be 3 over 4. So if you label your O, A, and H, you're just plugging in the numbers next to them into the relationships and simplifying. In this one, I want to write the three functions as they relate to x. X is over here. It's important to know what angle you want the functions for. So now the opposite side is 24. The hypotenuse is still 30. Oh, I guess I didn't write it there. That's my hypotenuse. And then my adjacent side is 18. So I'm just plugging in. The sine of z or x is opposite 24 over hypotenuse 30. The cosine is the adjacent 18 over the hypotenuse 30. And the tangent is the opposite 24 divided by the adjacent 18. And of course, I simplified all those fractions. So the thing we're going to end up using most with these trig functions is trying to find a missing side. We already know that we can find a missing side length two ways in a right triangle. The first way is by using the Pythagorean theorem, but we have to know two of the side lengths. The other way is by using a special right triangle, like an isosceles right triangle or a 30, 60, 90 right triangle. But of course, we have to have the right angles for that. In this one, I don't have a 45, I don't have a 30, and I don't have a 60. I only know one side length, 19, and so I need to use trig to find out how long this leg is. So x is the side across from the angle I have, and so I'm going to say that's the opposite angle, or opposite side. That's my hypotenuse, it's across from the 90, and so 19 here is my adjacent side. I always write down my three functions. And so I have x is my opposite side and 19 is my adjacent side. And so in order to use trig to figure out x, I'm going to choose tangent because it uses the opposite and adjacent. And I can write this equation. The tangent of my angle 65 is equal to the opposite side x divided by the adjacent side 19. There's functions on your calculator that say sine, cosine, tangent, and so I would just press tan 65 and it gives you this number. It's the value for the tangent of 65. And now I just have to solve this equation. Multiply both sides by 19 and get 40.75. I will show you in class how to do that function in the calculator. Let's try another one. I want to find the hypotenuse this time. And I'm using this angle that's 34. The side opposite is this side that's labeled 17. And so this side over here is my adjacent. I'm going to write down the formulas every time. And so I'm looking for the hypotenuse. And I know the opposite side is 17. So hypotenuse and opposite is sine. So I'm going to use the sine function here. So the sine of my angle 34 is equal to the opposite side 17 divided by the hypotenuse x. I could plug sine 34 into my calculator and get a value of approximately 0.5592. I'm going to multiply both sides by x here, or we can consider it cross multiplying. I actually could like divide this by 1 and cross multiply. But what I get here is 0.5592x equals 17. Divide both sides by that 0.5592 and find out the hypotenuse is 30.4 long. So let me do one more. Again, I'm going to label my sides. The side opposite of 26 is my O. There's my H, the side opposite the 90-degree angle. And there's my adjacent side. I'll write my relationships every time so that I can choose the right one. I'm looking for the hypotenuse. I know how long the adjacent side is. Hypotenuse and adjacent are part of the cosine function. So I'll say that the cosine of my angle 26 is equal to the adjacent 15 divided by the hypotenuse x. Plug cosine 26 into my calculator to get that decimal. And I'll solve for x. And I'll find out that that side, or that leg, is 16.69 long. So I have two problems for you to try. This one I want you to write the three functions like we did at the beginning as they relate to angle C. So do that first, and then there's one more problem where I want you to use the appropriate trig function to find a missing side. And here I've given you the value of sine, cosine, and tangent for a measure of 38 degrees, so you can use that number in your solving. If you have questions, make sure you ask in class, and you can check your answers.